Welcome back to IM1, everybody. Today's topic 2.11. How can I solve it? So, we're going to be looking at multiple methods for solving equations. And today's learning target is today I'll be able to solve one variable equations by applying different algebraic methods. So, problem one says review what you learned in lesson 2.11 by multiplying each expression below. First, decide whether you will multiply each expression by using the distributive property or by using an area model. So let's look at problem A right there. We have 6x minus 11 times 2x plus 5. So here the appropriate method would be to use the area model because we have a 2 by 2, two terms in the first parentheses and then two terms in the second parentheses. So let's set up our box. So we have 6x minus 11 and then 2x plus 5. And then here, again, we just want to multiply 6x times 2x gives us a total of 12x squared. 6x times positive 5 will give you plus 30x. And then 2x times negative 11 will give you negative 22x. And then negative 11 times 5 will give you negative 55. And then again, we want to write this as a sum. And then don't forget to combine the like terms. We have 30x and negative 22x right there. So we have 12x squared, nothing to combine it with. 30x minus 22x gives us a total of 8x, and then minus 55. And that's our product written as a sum. For problem B, we have negative 2x squared times 15x squared minus 3y. So here, since we only have one term outside and then two on the inside, that it would be more convenient for us and a lot quicker if you just use the distributive property here. So we're just going to distribute that. And then so this would be equal to negative 2 times 15 gives us a negative times a positive is a negative. 2 times 15 is 30. And then x squared times x squared. Remember, you just have to add the exponents, so that would give you x to the fourth. And then negative 2x squared times negative 3y. Negative 2 times negative 3 gives us a positive 6. And then x squared y. So there's nothing to combine there, so you just write them together. And that will be our answer right there. All right, and then let's look at the difference. So now let's look at the different methods to solve an equation. So to be prepared to solve an unfamiliar equation, it helps to examine all of the solving tools you currently have. So consider the equation. You have 4 times x plus 3 equals 20. So first, we're going to look at the first technique, which is called solve by rewriting. So it says David wants to solve for x in the equation 4 times x plus 3 equals 20. He said, I can rewrite this equation by distributing the 4 on the left side. After distributing, what should his new equation be? And let's solve this equation using David's method. So, like it says right there, it says I can rewrite this equation by distributing the 4 on the left side. So let's rewrite our equation. 4 times x plus 3 equals 20. So if we distribute the 4 on the left side, remember, draw your line so you know what's the left and the right of the equation. So 4 times x gives us 4x, and then 4 times 3 gives us positive 12. And that's still equal to 20. So this would be the resulting equation. And then we want to solve, right? We want to keep going to solve for x. So what we're going to do here, again, remember anything that's adding or subtracting, you get rid of first. So we're going to subtract 12 from both sides. And that leaves us with 4x equals 20 minus 12 is positive 8. Divide both sides by 4. Again, 4 times x there. Divide both sides by 4. To get rid of the 4, that gives you x equals 2. All right, and that's our first method, right? Solving by rewriting. Our second method is called solving by undoing. So it says Juan says, I see the whole thing in a different way. Here's how he explains his approach to solving 4 times x plus 3 equals 20, which he calls undoing. Instead of distributing first, I want to eliminate the 4 from the left side by undoing the multiplication. So what can Juan do to both sides of the equation to remove the 4? Why does this work? So again, the equation is the same one, 4 times x plus 3 equals 20. So what can Juan do to both sides of the equation to remove this 4 right here? So remember, we are multiplying 4 times x plus 3. Since it is a multiplication, to get rid of the 4, we want to just find the inverse of multiplying, which is dividing. So we can divide both sides by 4. And again, why does this work? Because the inverse of multiplication is division. And then part B says solve the equation using Juan's method. Did you get the same result as David? So again, we have 4 times x plus 3 equals 20. So Juan says we want to divide both sides by 4 first. So that's what we're going to do here. This eliminates that. And then you just have x plus 3 equals 20 divided by 4 gives us positive 5. And then again, we subtract 3 from both sides. And that leaves us with x equals positive 2. And then we get the same results as David. So what do you guys see? We did. So we can say we got the same result. Yes, we got the same results as David. And then part C says, why is it appropriate for this method to be called undoing? All right. So undoing. So in a way, when you guys want to get rid of everything else, right, you're undoing the order of operations. So here we are doing the inverse of each thing, right? So it's enabled to for us to undo a number. So it's called undoing because we are using inverse operations to solve the equation. And then we're going to look at our last method, solving by looking inside. So it says, Kenya said, I solved David's equation in a much quicker way. She solved the equation 4 times x plus 3 equals 20 with an approach that she calls looking inside. Here is how she described her thinking. I think about everything inside the parentheses as a group. After all, the parentheses group all that stuff together. I think the contents of the parentheses must be 5. So why must the expression inside the parentheses be equal to 5? So if you guys look at the original problem, again, you have 4 times x plus 3 equals 20. So just by basic times tables, we know that 4 times 5 must be equal to 20. So if we already have a 4 here, right? So we know 4 times 5 is equal to 20. And since I already have a 4 here, that means that x plus 3 has to be equal to 5. So that's the reason, right? Because we know that 4 times 5 is equal to 20. So therefore, x plus 3 must be equal to 5 just by matching things up. So now part B, write the equation that states the contents of the parentheses must be equal to 5, then solve this equation. So we already have it on top right there. It's just x plus 3 equals 5. Again, this is a quick step, right? You can still do looking inside here as well, because you can just say what number plus 3 is equal to 5. So we know that number is equal to 2, right? And then again, subtract 3 from 2, subtract 3 from both sides. 5 minus 3 does equal 2 again. And then again, did we get the same results as David and Juan? Yes, we got the same results. Same results as the other two.